Right, here's some three questions from the last review that you probably need to use logs to solve. So it says the value of a stock is given by this function. Let me just write that down. V of t equals 68 times 1 minus e to the negative 1.7t plus 36, where v is the value of the stock in months and t is time. When will the value of the stock be 96? So this is the value. So they want to know when that number is 96. So I can replace this with a 96 equals 68, 1 minus e to the negative 1.7t plus 36. And now what I need to do is I need to solve for t, which is up in the exponent. So what I first need to do is isolate that term. So first thing I'll do is I'll subtract 36 from each side. 68 times 1 minus e to the negative 1.7t. Whoops. And then I'll divide both sides by 68. Okay, and now 60 divided by 68. Let me do that. 60 divided 68, 0.8824, 0.8824 equals 1 minus e to the negative 1.7t. And now I'm wanting to solve for t, so I need to get this term by itself. So I need to get rid of the 1. Since this term is negative, though, I'm going to move it to the other side and make it positive. So instead of the negative, it turns out to be positive. I'll leave the 1 where it's at, and I'll move this to the other side, and so it'll be negative 0.8824. Okay, hopefully that is working for you. Now I'll subtract those. Okay, subtracting 1 minus 0.8 gives you that. And then I'm going to change this from exponential form to logarithmic form. So it'll be negative 1.7t is equal to log base e, that one, of 0.1176. And now that's the same as ln of 0.1176. And then I'll divide both sides by negative 1.7. So t equals 1.26, call it. So 1.3 years, maybe. Okay, so that's that question. Let me just answer the question. So the top says, when will the value of stock be $96? After 1.3 years. Okay, next question. This is a two-part question. It says carbon-14 has a half-life of 5750 years. Then it says they discovered an artifact that had lost 24.7% of its carbon-14, and they want to know how old the artifact is. This is a two-step question. I first need to find the growth constant, or in this case, the decay constant, and then I'll use that constant to find how old things are. Both steps will be using this formula. So P of t equals P0 e to the kt. So if they say half-life, you can start with any amount. P0 is the starting. So let's say start with 10. So half-life means that this 10 gets broken down into 5, or decays down to 5, which is half of 10. Okay, e to the k, and it says it takes that 5750 years. So there I've got an exponential equation that has a variable in the exponent that I need to solve for. So I need to first isolate this term here. So I'll divide both sides by 10. And on the left-hand side, of course, I'll get 0.5 equals e to the k times 5750. This is exponential form. I'll change it to logarithmic form. So it'll be k times 5750 is equal to log base e, that's that one, of 0.5. Log base e is the same thing as ln of 0.5. And now I'll divide both sides by 5750. So it'll be ln of 0.5 divided by 5750. All right, that comes out to negative 0.00012, call it, about that. So that's my K value of carbon 14. So now I can use the same formula, P of T is equal to P0 e to the KT. So now they want to know how old an artifact is, so they're looking for T, and they're saying it lost that much percent of its mass. So if it lost that much, it could have started at 100%, and if it loses this much, then that's down to 75.3%. So again, this is the start, this is the finish. So if you start with 100%, and if you lose that much, you're going to wind up at 75.3. Okay, times e to the k, I just found out what k was, negative 0.00012 times t. Now we do the same thing as we did in the other one. I want to isolate this portion, so I'll divide both sides by 100. So that'll be 0.753 equal to e to the negative 0.00012 t. Okay, divide by 100 both sides. Now change it from exponential to log form. So it's negative 0.00012 t is equal to log base e of 0.753. Log base e is the same as ln, and divide both sides by negative 0.00012. And that'll tell me how old the artifact was. The artifact comes out to be 2,364 years old. Right? Now, last question. Kim invested 7,000 in her savings account for 5 years. When she withdrew it, she had 8,000 bucks. And interest was compounded continuously. If it's continuous interest, then I can again use that same formula. So the question says, what is the interest rate? So I'm looking for K. So I started with $7,000, wound up with 8,422.53. E to the K is what I'm looking for, and that happened in 5 years. Same formula, I do the same thing. Divide both sides by 7,000. So on the left, I get 1.2032 about equals e to the k times 5. Change it to log form. So k times 5 equals log, that's an equals, base e of 1.2032. That's the same as ln, and I'll divide both sides by 5. Okay? So that comes out to a K value of 0.037. And if I change that to percent, because they're looking for the interest rate, to 3 decimal places. Oh, I'll move this over 2 places, so it'd be 3.7. And what I have on my calculator is another couple of zeros there. So 3.700%, that was the interest rate. All right, hopefully that helps you with those 3 questions.